Okay, today is the 16th of August 2008. I am Rob Campbell. I'm sitting here at the South Dakota School of Mines and Technology with Harry Orville, and we are going to talk about the T28. Harry, thank you for being here today. Could we start off with a little bit of your biography? Could you just sort of tell us where you came from, what your background is, and what brought you to School of Mines and the T28?
Fine. I'll start with my college educations. I went to the University of Virginia thinking that I'd maybe go into law school. I was a political science major. When I graduated from there in '54 and went into the service in the Army for 2 years, served in the Signal Corps and got involved in meteorology, which is weather. Went back to Florida State University to work on a master's degree, got a master's degree, finished in '59, and then went to the University of Arizona to work on a PhD in cloud physics and atmospheric sciences.
Your master's was in meteorology?
My master's was in meteorology. So it took me a little extra time, but I switched from liberal arts over to science and have enjoyed it very much. Got a call from Dr. Richard Schleusner when I was almost finished with my PhD, and he said he was opening a new group in Rapid City, South Dakota, and would I be interested in joining? And I said, Rapid City, South Dakota? Where's Rapid City, South Dakota? I was in Tucson, Arizona at the time. And anyway, he convinced me to sign on. I could continue things that I was doing in my research, which was modeling clouds, cloud developments over mountains, and did numerical modeling of them, and wanted eventually to get to thunderstorms. So it started a modeling effort in weather modification in cloud physics. Came here in '65, February of '65, reported the same day that Arnett Dennis did. So that's my background. I've been at the School of Mines I'd retired in the year 2000, fully retired in 2000, so had about 35 years here, and enjoyed it very much. Had a couple of sabbaticals. One sabbatical was back in Washington, D.C., served with NOAA, the National Oceanic and Atmospheric Administration, and that was in '72. In '82, I went to Geneva, Switzerland, and served with the World Meteorological Organization for a year, working on a weather modification project. And all the other years I've been here teaching, helped start the department with Dr. Schleusner and Arnett Dennis, and was head of the department from, I guess I was head from '74 till about '94, almost 20 years, with that 1 year out for a sabbatical.
You were head of the department and the institute?
I was only acting head of the Institute of Atmospheric Sciences when people would be gone on a sabbatical, like Paul Smith went on a sabbatical, and I filled in for him.
Oh, I see.
A little bit. I was also acting vice president for academic affairs at the School of Mines. 2 terms I did for that while they were looking for a permanent vice president.
So being chair of the department did not mean that the T28 program fell under your supervision?
Exactly right.
You were in charge of the teaching and the research.
That's right.
But not the T28.
Yeah, and not all the research. The institute was mostly research,
right.
But I was responsible for quite a bit of the teaching assignments there. So I didn't have I didn't have much administrative responsibility for the T28, even when I was acting head of the IAS. That was usually just 6 months or so, once or twice.
Can I back up and ask you about modeling?
Sure.
So you were into numeric modeling in early 1960s.
Mm-hmm.
And obviously this was always done through computers.
That's right.
Very different world. I mean, I'm just trying to imagine how you would do modeling on a computer in 1960. Just knowing nothing about those old computers and the mainframes and the cards or whatever you did.
Yeah.
Could you tell us a little bit about that?
Well, I was fortunate to be in on the beginning and had some of the early computers that I worked on. And I normally, when I got to the School of Mines, I had the National Center for Atmospheric Research, which was top-notch in computers. Before that, it was University of Arizona, and they had a very good computer back in the early 60s. So I was in on the ground floor of modeling using computers. I actually worked for a professor at Florida State using a hand calculator. Marchand is what it was. And you would punch numbers, and we were solving a Poisson-type equation, which is you solve it iteratively. There were two of us working on this problem for our professor. It took us 2 weeks to get a solution because we were solving over a grid, just like we do with the models now. But we had to use our own hand calculator to... You would
calculate each cell?
We do each cell.
For each...
Calculate each cell.
For each time slice?
Each time slice.
And fill in on a piece of paper?
That's right. That's right. And we did that, and it took us 2 weeks to get a solution, and the solution was good to two significant figures. He was trying to solve something about cold lows coming in from the Pacific into the United States, stagnating. So anyway, then the IBM, I think it was a 605, I'm not sure of the numbers, but it was one of the very first IBM computers came to Florida State University, and we were able to use it. And it took us maybe 2 minutes to get a solution to 6 significant figures. So I was sold on computers at that time. Having done everything by hand for a while, I was sold on how fast and how accurate a computer would work. And that was the beginning of my work in computers. When I got to Arizona, I had been in the Army at Fort Huachuca, Arizona, and I observed clouds forming over the Catalina Mountains there. And so I actually took photographs, stereoscopic photographs of the clouds forming over the mountains, and then I also did a numerical solution of upslope winds, which would result in cloud formation over the mountains.
This is while you were in the Army you did this?
No, the Army I was in Fort Huachuca, which is near Tucson, and I went to Florida State for the master's, and then I went from Florida State to the University of Arizona because I had that background around Arizona, and I knew I was interested in clouds.
And you went back to look at those clouds that you'd seen in the Army?
And to work on.
Wow, you took stereo photographs.
Yeah, right.
I'm just curious because my main research thing is landscape, so I'm fascinated with old photographs and how you document the landscape. Not that many people shooting stereo, I guess because it was science and everything.
It was science, and we had the cameras pointed at the mountains, and you could see them in stereo, and you can make quantitative measurements of the growth rates. And we learned that clouds were going up at 1,000 feet a minute or 2,000 feet a minute, and there were theories about how they should spread with time and things like that. So I was in the theory of cloud development over mountains in the early 60s. I finished in 65. I got my PhD in 65 and came to here.
So is 65 when IAS started up, or was it going for a while before you arrived?
It was going on for a while. There were consultants here. Even Dr. Schleusner was a consultant for a while in the early 60s, 61, 62. But it really got its start with Dr. Schleusner, I think, in 64. He came on board. He was at CSU as a consultant, but he came here. I think he really started things in early 64, got Arnett Dennis as the associate director, and hired me on as a professor, and there was a few other staff also. So it really got going. We started our field projects in the summer of 65 and 66 and from then on. So we were doing weather modification, cloud seeding experiments from that time on. And it really started around 65. And my modeling, I just brought my modeling from Arizona and just continued that development.
Mm-hmm. So is it your understanding that the impetus for IAS was Dick Schleusner?
Yes.
Or was it that School of Mines was looking to do this and they went and found someone? Or
Well, Dick Schleusner, I think Vince Schaefer, a famous man in weather modification and in atmospheric sciences, came here in the early 60s and saw the Black Hills and saw the cloud developments and knew it was a very good place for studying clouds, and he recommended that that the School of Mines start something up. Dr. Partlow was the president at the time, and he had the foresight to bring in Dick Schleusner from Colorado State University, eventually hire him to take over the Institute of Atmospheric Sciences, and we started the Department of Meteorology within a year or two of that.
And as it worked out, was a lot of your work studying Black Hills weather clouds?
Yes.
The Black Hills are a classic dome, almost like like an experiment.
Oh, yeah.
If you were going to build an experiment, it would look like the Black
Yeah,
Hills.
I mean, in the summertime, moisture's here, clouds form first over the Black Hills. And we took time-lapse pictures of the formation. We did cloud seeding studies. We flew through the clouds and found out if they had much supercooled liquid or ice or what their properties were. So the Black Hills have been a very, very good laboratory for cloud studies.
I'd like to ask you about money back in those early years. The funding for your research, and as much as you know, the funding for everything IAS was doing. Where did that money come from?
Well, that's the thing that really got us set up, was that the Bureau of Reclamation funded us with $500,000 a grant, which was a lot of money at that time, and that supported our work. So we had to write proposals for the Bureau, but the Bureau put the money in and had quite a project in weather modification, and they set up helped several departments start. I think University of Nevada probably got helped, and many people in this part of the country were supported by the Bureau of Reclamation in their initial research. And
their interest was specifically weather modification,
yes,
not
exactly.
Just basic science and cloud physics or anything like that.
They were more applied. They were the National Science Foundation, is where we went when we had to get other funding, and scientific funding. The more basic research was from the National Science Foundation, and I was probably about the first one in the state to get National Science Foundation funding for science, and I did that in the early 70s.
Oh, so the Bureau of Reclamation money carried you for quite a while.
Oh yes, it went
years and years.
It went. But the flood came in 72, and I think we probably were out of Bureau funding in a year or so after that. Yeah.
And just so I'm clear on this, the Bureau of Reclamation cares about weather modification. Why?
Because they are responsible for water in the West. So they were very interested in trying to increase water supplies. Snowpack, one of the main ways of getting water stored is by increasing snowpack in mountainous areas. And so they've been the front runner in a lot of research, basic and applied research in weather modification.
So in a nutshell, they want to know if you scientists could fill up their dams.
That's right.
They're in the business of rain, and they have a lot of western dams. They want more rain.
That's right. Exactly right. Yeah.
So you were here on campus, South Dakota School of Mines. Were you in McClory in those years?
Oh, we moved back.
You moved around?
We were at McClory for a while. We were the mineral industries, and at times we were split. I think Paul Smith's group was even in the basement of the dorm for a short while. So we were the main research on campus. We essentially started the research activities at the School of Mines in a major fashion with hundreds of thousands of dollars. And at one time we were significant researchers for the National Science Foundation. Later on we developed very, very nicely, producing a lot of master's degree students. We didn't have a PhD program at the time, but we were producing the 5th largest number of master's degree students out from universities in the United States.
You were the 5th largest program at one point. So thinking about how much you can buy with $500,000 in the 60s. I'm trying to put this in a neutral way. My impression of IAS in the 60s is that you guys had planes flying all around, radars all over the place, students running around, that it was just Fat City. Is that an accurate impression? That's a terrible non-neutral way to ask that question.
Well, it certainly wasn't all from the Bureau of Reclamation. We actually planned national projects and had national projects here. And when you saw a lot of airplanes here, it wasn't under the support of the Institute of Atmospheric Sciences. It was it was the Bureau of Reclamation. It was Colorado State University. It was other universities coming in. Paul McCrady's group came in, and the aircraft were from different universities, different commercial groups in the United States. And we called it, the first project was Hail Swath 1.
Project Hail Swath, right. So there were planes flying around and radar screens and people, but not all of them, or maybe not the majority of them, were IAS people or IAS planes.
No, they were million-dollar projects even in those days.
But they came to Rapid City.
They came to Rapid City, and we're here for 2 or 3 months at a time.
And they were doing their field work right around Rapid City in the Black Hills?
Yeah, always, it was well organized. Sure. Dr. Sloysner is a tremendous organizer. And so, we'd have briefings every morning. We'd see what the weather was going to be. We'd have certain tasks that were to be accomplished. And if the weather was one thing, we'd have one of those tasks. If it was something else, we'd have another task. So it was a very well organized project in weather modification.
Hail Swath, we're talking about.
Hail Swath was.
And so these people were all here doing one coordinated project.
Right.
It wasn't that people were doing all different kinds of projects at Rapid City. Oh, this was Hail Swath.
Yeah.
So was Project Hail Swath an IAS project, or did it
was a national project.
Right. But was it physically located at Rapid City, South Dakota, or was it at various places around the United States?
No, it was physically located here for its field program. Oh. But then the way things are done is you get your data and then you work on the research. You write proposals to NSF. You get funding and the Bureau of Reclamation. You get funding to do the research, analyzing the data that you've taken in that summer. And at the same time, we were doing. You'd have to check with Arnett Dennis and Dr. Sloysner on this, but we had weather modification projects going on in the Black Hills where we had 2 regions that were identified, and we'd seed one or not and take measurements of the rainfall in both the areas, and it was randomly seeded on a particular day. So we did our field projects on our own for weather modification, and we also did Hail Swath. Hail Swath was a major project on its own.
Obviously specifically for suppression of hail.
It was actually suppression of hail was the main purpose of the Hail Swath, right?
But increasing rain or snow is all tied in with that, right?
It's got a lot of similarities to it, right? And our other field work we did had to do with increasing the rainfall in these 2 areas around the Black Hills.
Now, when you say we, were you out in the field?
I'm a theory man. I was working on the computer and trying to get our cloud models to be something like the clouds that develop over the Black Hills.
You were here on campus taking the data.
Right.
So when you say we, you mean IAS in general and the program.
That's right.
And the data you got from this is radar data?
Radar was a lot of it, that's right. That $500,000 supported our radar complex.
Mm-hmm. The radar site out by the airport.
Right.
Aircraft data, which at this time was not penetrations at all.
Right.
It was...
Well, there were some penetrations because we had to determine were these clouds seedable. That's one thing you do, find out in weather modification. You have to find out, are your clouds going to be amenable to cloud seeding? And so you have to know if there's supercooled water, is there supercooled liquid in the clouds? And so you actually, John Hirsch and some of the others actually flew through the clouds, had a black glove that they put out the window and see if there was ice particles or if it was liquid. And
they literally stuck their hand out the window.
Yeah, you'll check.
And if it iced like the wing, then you had supercooled water.
Oh, right. That's part of it.
And I'm interested, obviously, because the T28 is always said to be this unique plane.
It is, right. And it was a development from this because one of the names I mentioned was aromatics, and that was Paul McCrady's group.
Right.
So Paul McCrady was the president of one of the groups that came here and measured clouds. There had been a lot of measurements of clouds down in Arizona, and I'd come from Arizona, and I knew they were doing work up in Flagstaff and all. And then they also continued to do summer work in other places. School, Rapid City was one of the places. And Paul McCrady, working with Dr. Sloisner and Arnett Dennis, came up with the idea of an armored aircraft to really penetrate the strong clouds. The clouds we were penetrating were much weaker clouds, the ones that were just starting,
right,
and were not that dangerous to people. But they wanted to be able to get into the clouds, the storms that were hailstorms.
So in these pre-28 penetrations, they would go straight through a cloud, but not a nasty cloud.
Right.
It's not the case that they would go right on the edge of a nasty thundercloud.
No.
They would say...
They might, I don't know, I can't say.
But that was not... I'm just very curious in what makes the T28 unique.
Yeah.
It's that those big, black, ugly clouds with lightning, they say that's fine for us.
Yeah.
Whereas this plane in 65 would say, no, we're not going anywhere near that.
Exactly.
Because that's just... And what kind of planes were they, do you know, in the 60s?
I know the name Baron Beechcraft, things like this, usually little two-engine aircraft. They had some single engine, but they had aircraft of various makes with instrumentation on it. The instrumentation on it could be quite good.
Sure.
But the planes were not that built for really strong updrafts and hail and things like that. The hail would normally hurt the aircraft.
These were quite ordinary airplanes.
Right. I'm trying to think when the King Airs came in. The King Airs probably were later. That was up in the 80s probably. But King Air is a name of some of the early aircraft that were used in cloud sampling. And
just to ask you the question I ask everybody, you know of no other plane ever that was like the T-28?
Right. No other plane that was armored to fly through severe storms.
As far as you know, well, you just said it. No other armored research planes.
Right. There have been military aircraft that have gone into severe storms by mistake, usually. My cousin was caught in a Navy pilot of the aircraft carrier was caught in a storm that took him up to 50,000 feet or so and spit him out. He said he lost complete control of the plane. So, but he didn't do that on purpose. But military aircraft would probably have the strength to go into severe storms. But it was really the T-28 that was designed specifically to go. And even that, there's limitations on that. I think the radar reflectivity couldn't be greater than 53 or 55 dB. And so there were limits there too.
So Project Hail Swath was physically a Rapid City, South Dakota project.
That's right.
Do you remember how many years that ran? Or
it was just 1 year, the first year.
Oh, 1 year.
Yeah.
And this is before ENRI, the National Hail Research Experiment.
Yes. It was a precursor to ENRI.
It was a clear precursor to ENRI.
That's exactly.
It was almost a prototype for ENRI,
right,
which came soon after that.
Right. That came in 72 or something like that. Or I'm not not sure exactly. You probably got the dates on that.
And Hail Swath was, Hail Swath was the late
66
60s
or so.
something.
60s, yeah.
And so Hail Swath, you believe, was a one summer.
And I'm not sure of the date. It could have been 68, sometime
Yeah.
in the late 60s.
Can I ask you about Paul McCready?
Yes.
You knew Paul.
Yeah.
You knew him well.
As a scientist,
Okay.
would be in meetings.
Well, I'll just put it this way: the T28 was Paul McCready's idea. Is that true, or he was instrumental later, or he? What was his role? I guess is my question.
Person's idea. Who's the originator between Schleusner, Arnett Dennis, and Paul McCready? I do not know.
Okay.
They know, and they would tell you who they thought originally came up with the idea. They all were involved, and certainly Paul McCready had a lot to do with realizing the feasibility of it, because he was the aerodynamics person and all, and he was pretty sure they could work it out.
Paul McCready was an interesting guy.
Yep, he sure was. I got him here as an eminent engineer for one of our engineering week celebrations, and he fascinated everybody with his discussions of his airplane that they designed to go across the English Channel. He was a tremendous innovator.
And did you? I'm not putting words in your mouth, but did you say that he was here for Project Hail Swath?
Yo, sure. Yeah, he participated in the morning briefings. He was president of his company, so he probably had to leave and go other places. But at times, he was certainly here and participating. He's been in our faculty lounge many times, sitting around.
He
talking.
was here in his role as. His company was officially involved in Project Hail Swath, getting government money, spending it, and his job was the planes, I imagine, or?
They supplied at least one of the aircraft, a pilot, and some of the research personnel. And Paul McCready himself was a good engineer, a good scientist.
He's a meteorologist, right?
He knew his meteorology, he's an aerodynamicist. He thought that weather modification worked from what he had seen. He'd seen a lot of evidence of weather modification affecting the clouds significantly.
Okay, so now we get up to the time of the T28 itself. So as someone who is using these data as a modeler or researcher, what did the T28 mean?
Well, it's provided some critical data from inside clouds, but I'd like to tell you about one little story.
Sure.
In the beginning of the T28, when it was being planned, probably 72, the summer of 72, I had been fortunate to go to NATO institutes, research institutes in the summer, one in 69 in England and one in 72 in England. And in 72 in England, to talk about the modeling work that we did and all. But I was also able to brief them on our Hail Swath work, and I was able to brief them concerning the development of the T28. This is something that we're going to do in the United States. We're going to armor an aircraft. We're going to fly it through severe storms. And the English scientists there just threw up their hands and were just couldn't believe that we would do such a dumb thing because we were going to ruin cloud physics. It was going to crash. It was going to run into disaster, and we wouldn't be able to carry out the type of work that we would have wanted to do. So they were very much against arming an aircraft and trying to fly it into severe storms.
They threw up their hands in dismay. Not anger, but dismay.
Yeah.
Because you were going to be a spectacular failure that would blacken the name of.
Some of them thought it was a bad idea, knowing about severe storms. They thought it was just the odds against it working were not that good.
They were all forgetting these data, but they thought you would fail.
Right.
That's interesting.
So that was in '72 when I was there. So that's got to be about the dates, you know, that we were starting to
Right, just when
the airplane
testing
developed
it
and getting it in. Right?
That's funny.
Yeah.
What was the closest thing to T28 data from inside the cloud, in situ data before that? I mean, did weather balloons go up through these? I mean, you must have been scrambling around for any kind of data you could get as close to these thunderstorms as possible, right?
Mm-hmm. In fact, when I was in Arizona, I had flown in a B-22, I think it was, that we had flown through clouds that were forming over the Catalina Mountains. And at times it got so rough in there that said, we've got to get out, turn and get out of this cloud. So back in the 60s and even in the 50s, people were trying to get into the clouds. There's no doubt about that.
Mm-hmm.
But it wasn't, when the clouds got too severe or too strong, updrafts were too strong, or you did run into hail, that was something that chased you out of the cloud very quickly.
You got out immediately.
Right.
So were those pre-T28 data useful to you as a modeler?
Oh, sure. Oh, my goodness, yes. There was a lot of theory about how much water, how much rain would form in clouds, and what caused hail to form and all. So there were measurements going on, but it was in the preliminary formation of the clouds. It wasn't the latter, very mature stage. And of course, the thunderstorm project started right at the end of the Second World War, where they used a lot of military aircraft and all to try to study thunderstorms in the Midwest and also down in the Caribbean. So their project, the thunderstorm project, was one of our first projects where we tried to study the severe storms.
Is that what it was called, the Thunderstorm Project? Or?
Yeah, I think that's what the name
That's
is.
good.
Right.
So is this this scientific story, is this a story of meteorologists inching closer and closer to the heart of these storms?
Kind of.
Kind of?
That's a good way to put it, yeah. And particularly in our work here, we emphasize the concept of feeder cells. Sometimes you can see a big storm and you see cells seeming to move right on into the major storm. And so you would concentrate on those feeder cells. And this is something that our people have emphasized. And so it's you know, you can go into the feeder cells, but you're not there when they become the major cell.
So the feeder cells would sort of merge into the thunderstorm, right. Add their energy?
And they would add their energy, their water, all right. And that would be another burst of hail at the ground or something like that.
And the reason that you focused on the feeder cells, was it because feeder cells are a fascinating phenomenon, or was it because the feeder cells were safe enough, small enough to study?
They were safe enough and small enough to study, but they seemed to have a very important part of the process of the storm in general.
So both.
Right, right.
But definitely part of the interest was because that was a cloud you could tackle.
That's exactly right.
Small enough to really
their tops would go to 20 to 30,000 feet, something like that, you know, and the major storm might be up to 40 or so. And you couldn't get into the major ones, but the ones moving on in, you could.
I'll ask this very broad scientific question. I'm not even sure this is an intelligent question, but let's say in meteorology since the 50s or so, has there been one point where something really clicked? One, sort of plate tectonics moment in cloud physics meteorology. You know what I'm saying? Or even just specifically, I mean, thunderstorms, how hail develops. These questions that the T28 is involved in. Or has it been a pretty gradual?
I would say it's been more evolutionary, right? And the T28 has certainly provided some very good information on the updrafts and confirmed some. Before people get into their field studies, it's necessary really to have a hypothesis or to have concepts that you've developed, and so So there's these qualitative concepts that are there, and then it's the T28 and the models and all that make things more quantitative. But the radar is certainly the radar doesn't show the circulation in the cloud, but it gives good hints to it. And the T28 could measure the updrafts, measure the downdrafts, know where the hail was, where the rain develops. So it clarified a lot of the preliminary concepts that people had.
And because just as I've been trying to read some of this literature as a total outsider, I don't see one moment where the community says, "Oh wait, that was wrong." It turns out that this is the case. I don't. At least there's not that one obvious moment when half the people say, "Oh no, we're the whateverists," and "No, we're the whateverists," and there's a big battle, and it turns out that the young rebels win, and the old,
Yeah, well, the Russians had some theories about hail formation and I'm trying to think of if it was the development of heavy rain or hail, but the T28 and radar measurements sort of disproved their initial theories on it. And I would have to get back to you on the exact terminology that was used at the time.
It's been a few.
That was back in the 70s and all. Yeah. So there have been certainly some times when certain things were believed, but eventually disproved.
I've heard about the big drop zone.
Yeah.
Is that what?
Yeah, that could be part of it and all, right. Yeah.
Did you talked about going over and meeting with the Europeans. Did you ever have any interaction with the Russians? Were they major players in meteorology?
Yes.
They were?
I would say so, sure. In weather modification. Yeah, we dealt with, when I was spent my year with the WMO, I was scientific leader of the PEP project, Precipitation Enhancement Project.
I'm sorry, the
Precipitation Enhancement Project,
yeah.
Called PEP. And that had people from many, many nations involved in it. The Russians were certainly part of it, French, English, Australians, United States, major players in trying to design an international program which would tend to support, give new evidence for weather modification.
So there were major players in a lot of different countries.
Yes, right. And the Russians claimed 100% suppression of hail. They had it all taken care of.
They did?
Oh, sure. So they didn't have very good statistics, and it's never been upheld that much, but the Russians at one time were probably the major players in some weather modification work, and particularly hail suppression. Right now, I guess it's the Chinese who are the primary.
This week at the Olympics, right? Or maybe that's for rain. That's for smog.
It's to try to help get rid of the smog, because if you can make it rain more, you'll help clear up your atmosphere. But they were certainly major players there.
But so you dealt with the Russians face to face?
Oh, yeah.
In committee rooms?
Sure.
And so what was that? I mean, obviously this is the time of Cold War and putting a man on the moon and all of that. Did that bleed into science?
You could always discuss science with the Russians. It seemed to me they had their thoughts. There were some very good scientists, very good radar meteorologists. Dr. Smith is good friends with some of the Russian radar meteorologists, and I was chairman of the Weather Modification Committee of the World Meteorological Organization for about 8 years, and we always had a Russian on our committee. Usually a committee made up of 8 to 10 people. So it's a fascinating business. The meteorology or the weather, is so international that you get people from all countries involved in it, and some of them do some very good work.
You sort of can't ignore the weather.
Sure.
Everybody has to deal with it.
Right.
Everybody has to do something.
Right.
Try to do something. So you said the Russians claimed they had 100% suppression. So, were they lying? Were they mistaken? Were they?
Well, they were probably trying to convince their bosses that it was a good thing to be doing. But I don't think anybody's ever shown or would ever be able to show 100% effectiveness in hail suppression or rain increase. But they were always very positive about what was happening.
But they were cooperative with people from the United States and other countries. They were open with their data.
We had meetings, we had international meetings with people from all countries there, arguing about the way to do things, So,
would they share their data?
I don't know how. Through the WMO, you were supposed to share data. You were supposed to provide your data, and people could check it. I never tried to analyze their data, but I don't know if Arnett Dennis has or some of the others you might talk with.
But it's definitely not the case that they were operating on their side of the wall. And can I just ask you in general about weather modification?
Sure.
It's appropriate that we're in a classroom here because these are the kind of questions. Again, from the small amount that I understand, weather modification is so interesting because it seems to have been an open question for the last, 40, 50 years, many decades. And it's not the case that this is just, this is not divining rods and this is not hocus pocus. But it also seems to be not the case that scientists now completely understand. They say, well, everybody agrees that this is what happens. At least that's my impression. And it seems to me to be an unusual sort of gray area. Not gray area, but it's a funny question in science. And I know you were obviously working on this for many years. Can you give me a brief primer on the effectiveness of weather modification?
Weather modification has some very definite effects on a small scale that many people have seen. You can write your initials in certain types of clouds. And those initials, that's where you put the silver iodide, you've changed supercooled liquid to ice, and it's snowed out on the ground. Those are rather small scale effects. And the airlines use cloud seeding to clear weather at the airports. It's used routinely in Salt Lake City.
Really?
Yeah. They'll clear supercooled fog, clear the airport, and they'll allow landings to be made. It saves them millions of dollars a year.
And you definitely can make it rain. You definitely can make it snow. You're saying on a small scale.
Yes.
By giving the supercooled water nuclei or embryos.
Yeah, and being able to change it from.
And that gives them something to form on. They drop to the ground.
That's exactly.
That definitely works.
Yeah.
Now, it sounds as if you're going to make a distinction.
Well, those things are pretty well agreed to. There's some very dense people that maybe still say no, but in general, that's pretty well accepted. But the problem is when you try to get to large areas and large time scales, and can you really, over an area, make it increase snow by 10, 20% on a season? And that's when it gets much more difficult to show. Well, can you increase the runoff into rivers? And there are some, usually you can't do this on a randomized basis because the people supporting the work want the rain. They don't want you to seed half the time, not seed half the time, and tell them what the statistics said. There's a few statistical tests that have been done, and that's what we were doing in our work in the 60s here. So it's a matter of scale. On the small scale, it's very obvious, airports and certain types of clouds, the supercooled stratiform clouds, not the cumulus type, but the stratiform clouds that you can affect, and that's what snow comes from. So snowpack in the west is a stronger more strongly accepted than seeding the cumulus clouds in the summertime. And hail. Hail is all comes from convective clouds, cumulus clouds, and it's on a large scale, and it's a much harder thing to prove.
And hail is people have explained to me that hail is so rare anyway that a good statistical sample takes a lot of money.
That's right.
A great deal of money.
A number of years to do it, right.
Yeah.
Right. North Dakota's been working on it for many years now, and they have evidence that seems to look pretty good. We have modeling evidence that indicates when things work, seem to work, And this is something we used the T28 for. Dick Farley, who's one of our cloud modelers, designed the hail process for our models. He was the main person to put the simulation of hail into our thunderstorm models. And he made sure that the categories of hail that he simulated were consistent with the category of hail that the T28 measured. This is something I wanted to get to with respect to the T28. When we knew the T28 was being developed, it was going to have a hail sensor on it. It was going to measure hail in these categories. And Dick Farley made sure that our models also put hail in those categories, or would simulate the hail development in those categories. So we have some of the first modeling work that came out that would show T28 observations and what the hail model would say was supposed to be developing, and they were very consistent. So
because the model was designed for T28 data to plug right into it.
That's right.
And line up.
Yeah, right.
By the way, were you a programmer? Were you a computer programmer? Are you a computer programmer?
In my early days, I knew that 61 was add and 62 was subtract, and I was in the very beginning where numbers, that's how you did it. You had a 10-number address, and 2 numbers were what the function was, and 1 was where you stored the data, and 1 was where you got it from.
Like machine language.
Yeah, all machine language.
But you didn't end up, writing Fortran and COBOL and all that.
My dissertation was Fortran.
It was.
Yeah. Cloud development over mountain. But the work we did with the T28, I was on committees and I helped it get into projects. It was on one of the first projects, or one of a good project for it was run out of Huntsville, Alabama with NASA. And so that the T28 made measurements of the severe storms down in the southeast part of the United States. That was my administrative work with it. I'd be on committees and had to talk about the science of a project, and I said, you get the measurements in the severe storm from an armored T28, and we were able to do that. And then to have our modelers, people that I worked with, design our models to work and be able to use the T28 data to verify what was going on in a cloud, in a severe storm.
Can I ask you specifically about ENRI?
Yeah.
You must have been involved in that for quite some
A
time.
national hail research experiment, yes.
Are you familiar with sort of the funding politics behind ENRI? I'm interested in this issue of, well, I guess it's 3 actually. You have basic science. You have specifically weather modification. Basic science, how does a cloud work, how does hail work? Weather modification science. And then just operational weather modification, as you said, they just want you to seed. And then if you find out, it seems to me, just listening, talking with people, that ENRI was sort of moving around or pulled around, or definitely somewhere inside that tension. Does that make sense?
Yes, but ENRI was probably more focused on the basic science of it. And they did get some operational applied work done. just to seed for seeding, that wasn't part of it really. Your third aspect was not a,
Right.
that's an important component of commercial cloud seeding. In the States, and people who want cloud seeding to produce something, they're the ones that seed and don't worry about the evaluation. But ENRI was basic science, and the applied science, it was going to be evaluated. You were going to evaluate the seeding you did on the clouds. So that was always an important part of it. I think there was a little bit too much, let's learn all the basics before we worry about any of the applied work. I think there was too much of that in ENRI. They had very good scientists, but they weren't very practical. Sometimes would think you have to know all the basics before you can do any of the applied. And that's not my philosophy.
Your philosophy is?
Well, you can certainly do a lot of applied while you're learning what the basic science is. And you use, actually we always would emphasize, use the cloud seeding as a tool to show that you know what's happening in the basics, because cloud seeding can change the basics and you can measure those changes. And that'll really let you know that you understand what's going on. But sometimes there were some scientists that didn't even want you to use any seeding material until you learn more about the rain process and more about the hail process. And that never made any sense to me.
And there was seeding going on in ENRI, right?
Yes.
Same as Project Hail Swap.
Yes.
Both had a seeding component.
Right.
Did ENRI get shut down? I'm trying to remember. Was it is it accurate to your memory that it was a 5-year program shut down after 3 years? Because
They showed that even with they showed with what the data they had was not going that positive that within 2 more years you could have a definite answer. And so if you couldn't have a definite answer in 2 more years, then let's shut it down. Something like that. I'm not sure. But you can do the preliminary statistics and you know if things are going along in the way you expect. And they bit off a big chunk. You know, they were severe storms they were working with, and your number of cases is not going to be that great. So there was a lot of discussion by the scientists. I was in on some of it, whether or not to continue, and they thought that the statistics just weren't going to prove things out within the time period that they had left to do things.
they didn't think they would get a definite answer one way or the other.
Right.
It's not the case that, and this is a question, it's not the case that ENRI was showing that weather modification was ineffective. It's not the case that ENRI said whether seeding doesn't work, so we're not going to fund it anymore, or is it it's the case that they said, well, this isn't going to give us the answer.
Right. It's not conclusive, and it definitely wasn't that it was proving it wasn't working. There were good indications at times, but there, it wasn't enough of it, as far as I remember.
And ENRI was an NSF project, correct?
Yes. Right.
Oh, that led me to something I was just going to ask you. Sort of going back to something you said. Why is it then that whenever I think of this, all of this research that I hear about is summertime research? Am I wrong? Well, the T28 only flew in the summer. Flew research missions. Mm-hmm. Is wintertime... I understand thunderstorms come in the summertime.
Yeah. There's a lot of work that's been done in the wintertime. And the more conclusive work in weather modification probably is done with wintertime, seeding, cloud seeding, fall, winter, and spring to increase snowpack.
It's just
there's more evidence that shows that work. There's more indications that that's working. There's more commercial work going on in wintertime cloud seeding in the world. There's a lot of wintertime cloud seeding. So snowpack enhancement is used in the western United States every year.
So it's just that I've been talking and reading about the T28, which is a summertime instrument.
That's exactly right. And in weather modification, that's the more difficult time to evaluate, the more difficult clouds to evaluate. They're more dynamic. They change so rapidly.
Yeah.
If they change